Problem 6, Zigzag conversion. So to solve this problem, there's really not many concepts, it's just clever thinking. And it's not even that clever actually, it's just doing what the problem says. And what I mean by this is, so we have the zigzag conversion problem, and it states we're given a string and a integer n, or rather num rows, and it describes how many rows there are in the zigzag. So for example, if n is equal to 3, then that means we have like boom, 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 we have 3 rows, and then we zigzag in a pattern that looks like this. So that's the problem, and we basically then return the string that's read row by row, left to right. So it's this, this, and then this. And we're basically trying to find what that string would be. And to solve that problem, we just do exactly that. We're going to create the zigzag pattern and store it within arrays. So the number of rows, in this case 3, will dictate how many arrays we need to store it. And it's going to be stored in a 2D array where each of the internal arrays represents a row within the zigzag. So the first row in PayPal is hiring is going to be I already gave it to us. It's going to look like this. The first row is PAHN. So here's going to be PAHN. And then the second row is APLSIIG. And then the third and last row is YIR. So that's what our final array is going to look like. And then what we do is that we simply turn each of the internal arrays into a string by doing .join in Python, and then put that with a variable, let's call it s, to get the final result. But the question is, how do we get these values stored in each of the arrays? Well, the way we're going to do it is that we know that the way it works is it's going to fill it up, down, up, down, up. And what I mean by this is, consider PayPal is hiring, right? Simulate the process. P-A-Y, we went down by 3, which is the number of rows. Then we go P-A, we go up by the number of rows, and then we go down again with PayPal I, right? And then we go up again, S-H, and you see where this goes, right? It just keeps going down, up, down, up. And that can be simulated, right? Where the first row here is all going to go into the first array. So this is going to be row 0, row 1, row 2. We store these local variables, and we have a variable direction that tells us when we need to go down, when we need to go up. And that's dictated by num rows. When we know that when we hit r is equal to 0, we must go down. And when we hit r is equal to 2, we must go up. It's very simple. So I'll program it up, and it's going to be very clear. So first thing is, what is an edge case for num rows? Well, num rows is defined to be within 1 to 1,000. And what happens when num rows is 1? Well, it's just a string itself. So if num rows is equal to 1, then that means we just return the string. Otherwise, we have this zigzag pattern that we see in the example, and we have to get the 2D array pattern that we discussed in the example. So we have to store this in a 2D array, and the number of arrays within this 2D array will be dictated by the number of rows, which is num rows. And what else can we say? We now can iterate through the string. So for each character in the string, we append the current character into the current row. The current row, we always start at 0, and the current direction is always 1. Current direction is 1 because why? In the example, we said that we started 0, then 1, 2. In the example of num rows being equal to 3, then we go back down to 1, 0. Then we go up 0, 1, 2. The point is, we always go up by 1, and we go down by 1. So plus 1 minus 1 controls that direction. So therefore, r of the current row will be appended with the current character. And then we simply have to check the conditions. If the current row is at the bottommost row, then the direction has to be 1. And if the current row is equal to the last row in the diagonal, then in the zigzag, then the current direction has to be minus 1. And then we just simply do cur direction, or rather current row, right, plus equal to current direction. This will update the row accordingly. And now we have stored through this chunk all the corresponding characters in each level. And we just have to turn all this into a string, append it together, and then return it. So let this overall string be s. And for each row in R, we're going to concatenate it with s. And we have to turn each array into a string. That's done by using the join method, where we .join row. .join row turns it into a string, and we basically join that with an empty string so that ultimately it's going to be the string representation of the array, and we concatenate that with s. And with that, we just return s, like so, and we should be good. So let's run it. And this is, oh yeah, equal to, because the equal sign is the assignment operator. So let's do that, and that should work. So, oop, num, oh yeah, wait, what is not cur row, num row? Where did I do num row? So we do cur row here, and then we run that. List index out of range. So we have to add, we should add this before, right? Let's add this here. But it shouldn't matter. I don't know why it's doing this. Oh, right here. It should not matter if you add it before or after. But what's the issue here is that it should be cur the num rows right here, not cur row. That should fix it. There we go. Now we can submit. And there we go. That's the solution.